Yes, so we can just get started on the panel discussion, which is the idea here is because we have industry experts with us today, we would like to take advantage of whatever technologies that they've talked about today and they've shown. How can we get our hands on them? That's the idea, no? So we can, I'll sort of, to get the ball rolling, mostly we'll be opening the floor to questions from the audience here and online. But just to get the ball rolling, maybe I started off with a question. So it's a general question, not directed to any of you. Thank you for joining the panel, Dr. Nakakura, Dr. Oleynikova, Dr. Delmerico, and Dr. Liu there online with us from UK. Very early in the morning for him. So just to start off, do you think that the adoption of, now we've seen quite a few talks, especially from the industry perspective, do you think the adoption of XR devices and technologies is too fast, too slow, just right? Or is there a, because we generally get to hear that there is more of a push for these devices than a pull from the market. What is your perspective on that?
I can start. It's a little bit of both, I think, the push and pull. So at least my understanding of sales for HoloLens 2 devices since it was released, there was greater demand, at least for a while, than supply. And so that's a good sign as far as, you know, adoption in the market for mixed reality devices. But at the same time, the actual usage in the real world industrial scenarios, you know, for the customers that buy these devices, it's, at least to me, not clear that they're used as effectively or as completely in by those customers to really improve productivity. It's I think a lot used for more innovation side R&D and exploration. I've seen in person a few really useful examples where it's the capabilities of mixed reality are used very effectively in an industrial setting for a particular task, but broad adoption, not clear yet. So I do feel like we're lagging a little bit behind, and some of that may just be that it's still a bit forward-looking, and companies, particularly in the current economic environment, maybe aren't willing to risk investing fully in transforming their entire, you know, all their processes to something that uses this kind of technology when it is a bit unproven in real-world scenarios. You know, obviously there's more evidence slowly that it's useful in a lot of scenarios, but I think it's been maybe a bit slower than I think probably everyone in this room would hope.
Yes.
Yeah.
Maybe I can add a little bit to that. I think like XR technologies face a lot of the same problems that robotics adoption and commercial scenarios faces, that, you know, if you want a robot to make a task easier, or if you want an XR device to make a task easier, the first time that somebody tries it out, it needs to really work, and it needs to work perfectly, or the person gives up and does it the old way, because the old way works. And if this new way doesn't work 100% of the time, you're going to have a really hard time getting adoption. And I think frankly, XR technologies are maybe even a little bit more mature than robotics at this stage. But I think they suffer from the same problem, that it's really hard to go from nothing to works 100% of the time without really investing massive time and resources into making things robust. So I think that's, I hope, where, you know, we see great gains in both robotics and XR technologies soon.
Very good.
Yes, and today I feel that the difference, the mind between Japanese owner, Japanese project owner, and international owner. So my how can I say, my client every time say, yeah, your AI and your robot is really excellent, but what if your robot will get out of control and it damage our clients, our asset? Every time they say, and I'm totally got exhausted with the discussion. And today how can I say, I really amazed about the presentation, his presentation, Dr. Liu. Yes, and I envy he can deploy such a brand new technology. And yeah, that's my, that's how can I say? Yeah, that's my trouble for my. So, how do you think your client is, how can I say, really brand new mind and very interested in deploying new technologies?
You think that the client should have a forward-looking mind?
Yes, I can say business person in US and the EU, can say really want to deploy brand new technologies, but yeah, I think so. But how can I say? Is it so in the actual? I guess. Sorry. It is. Oh, sorry. I cannot explain in English, but yeah, that's my problem. Yes.
Dr. Liu, if you want to jump in on that, if you had a point to make.
Yeah, I guess from our perspective is that what we see so far, specifically just for the XR technologies, I feel like still majority of the adoption is in the gaming industries. I think there's a strong trend to apply it to a bit more in productivities and general working scenarios like new Oculus Pros and HoloLens 2. Yeah, I think in terms of using XR in robotics, so I still think that is very early days where mostly it's the research innovations and early adopters, which is looking. I think people are waiting for something that could give 10 times improvement compared to current available technologies. So some use case that could enable 10 times like a killer application for it, which is actually what we are spending a lot of time working on, talking to everyone, figuring this out. And the other thing is I think as XR used in robotics, it's more of, because XR is just a small part of the complete solution. It's just a user interface aspect of the entire robotic application. It's quite dependent on the adoption of robots. So yeah, so I guess if the robot could be adopted a bit faster, yeah, so that could help with this XR used in robotics. But also hopefully when the robots with XR is more useful and more easy to use, it will push the adoption of robot itself a bit faster as well. So they could hopefully propel each other and come to the new field. Yeah. Thanks.
Thank you for the interventions, all of you. Did anybody on the floor? I would like to open the question. Please go ahead. So you can go first, and then lady.
Hey guys, thanks a lot for all your presentations. They were all kind of coming from different angles on different industries. And I would like to piggyback my question on what Helen said, that there is this need to be excellent from the first go to get adopted, and I completely agree with this. So I would like to maybe ask you, like, if somebody would press you, like a guy asking questions at a panel, to pick like the one next thing that is breaking this 100% adoption thing, right? Like, what would be the hardest next step to achieve in order to get rid of this one step that is breaking all the workflow? Thank you.
I'm holding the mic, so maybe I go first. From my perspective, actually, so in terms of like XR, it's actually kind of a boring answer because it's not cool and technical and researchy. Like, I think the tooling for making XR apps is pretty terrible. It makes it really hard to make good ones. So I think it's kind of a low-hanging fruit, but I think if we can improve that, then I think we can make it much easier to make stuff that actually works and test it and so on, right? Like, also testing this stuff is awful. You need you know, tons of time, tons of equipment. You need to always be in the immersed in the thing to test how it's working, and this just slows down everything.
At least from the Microsoft perspective, and I heard this from several of the talks today, one of the biggest things preventing at least HoloLens from being used maybe as often as it could be is field of view. I mean, other aspects of the hardware design, like battery life and form factor, are also important, but the field of view really takes you out of the immersion of the experience. And that's obviously something that you don't, that's difficult with mixed reality. If you want to be able to see the real world and have also a crisp digital display over top of it, it's a challenging problem. We're not there yet. But I think until that improves from the hardware side, it's going to be difficult for, I think, a lot of consumers or businesses that want to use at least Microsoft headsets in the real world. It's going to still be in kind of a limited capacity. And so for anyone who mentioned the field of view in their talk earlier, we're working on it, but that's all I can say.
We can go to the next question.
Okay. Hi, I'm Christina Jokinen from AR Research Center in Tokyo. Thank you, first of all, for really interesting and inspiring talks by all of you. I have two questions. One is related to using this technology for the point of view of health effects. Because one of the things, at least when I have tried some of virtual reality equipment, is actually that it can, for a long use, make health aspects. So how do you take into account that kind of sort of aspect in developing the technology and making them more available for the users? Another question is a bit more philosophical, because in a way, when we want to have our users immersed in this virtual world and kind of extend our capabilities, that also kind of blurs the distinction between what is real and what is virtual. And I guess there are a lot of issues related to ethics and things like that. And my question, second question, is related to do you think this kind of a demarcation between virtual and real, is that a kind of a problem now or in the future? And what do you think about that in general? Thank you.
I think those are both very interesting questions. And my answer to both, at least this is my personal opinion, not Microsoft's, but it probably aligns pretty well with the Microsoft view as well, is that I think the mixed reality where you can blend both virtual and real world elements in the experience is important for both of those things. For one, with health effects, with any kind of motion sickness from a purely virtual environment, it allows you to utilize your regular kind of spatial perception and in viewing the real world as you have an experience in mixed reality, which hopefully, at least in my experience, there's maybe a little bit of eye fatigue from viewing through the display on a HoloLens, but in general, it's significantly less than a motion sickness, anything like that, compared to a full virtual experience. And to the second question, I think mixed reality also offers the ability to make clear what is real world and virtual, and avoids maybe some of the ethical questions that you're referring to there. Is that if you can always kind of turn it off, so to speak, or at least be able to recognize your environment in the real world while seeing digital stuff on top. That also, I think, can help resolve that.
As for the first question, I have experience to help LI people. She cannot attend the wedding party of her grandson. She was really, how can I say, she really old, and how can I say English improperly? She is it correct? But she is bedridden, and she cannot go to the ceremony hall. And I set the robot in the ceremony hall, and I set up many sensors track her eye. And I let, how can I say, my system use her eye motion. My robot, according to her eye gaze, how can I say, the robot and the bride can hug each other through the system. And it is, how can I say, my motivation to create the telepresence system. And yes, yeah, I will create more new technology to help such kind of people. So yeah, I think that's a good, really good question. And yeah, sorry, that's all.
Maybe I can add a little bit on top of that. So in terms of the how, I guess, around the healthcare aspect, yeah. So part of what we wanted to do as well is to utilize this remote robotic teleoperation robot for example, like a care home or healthcare general service sectors where it seems with the aging populations, there will be a lot of need or like a lack of labors in those areas to serve elderly people, and allowing remote operations of those care home or hospital nurse to for example work remotely for like boring tasks. I think a lot of the operations in the hospital care home are quite logistic focused. They're not like take care of the patients, but a lot of like logistic, moving things around, and a lot of time actually wasted in those tasks. But with teleoperation robots, I think there's a potential that you can almost delegate all these tasks out to remote operators, and having the physical nurse spend more time talking to elderly people or patients and take care of them. And yeah, so that could potentially improve the efficiency. And the other thing for mental aspect, I guess it will highly depend. For me, it would highly depend on the applications. So obviously, in any technology, if you abuse them, then you probably have negative potentials. But I think a lot of the technology, a lot of the use case, for example, you can see your relatives very far away that you cannot talk to in person. You can talk to them virtually, almost in person. If the rendering could be almost a reality equivalent, indistinguishable from reality, and then yeah, I think it will feel a lot more engaging compared to Zoom calls to relatives, and if you miss someone, you can almost teleport next to them, having a good conversation with them. So I think there's a lot of positive side of that. Yeah. So I think just want to highlight that point. And
take the next question.
Thank you. This question is probably more for Helen and Jeffrey. I mean, it's great to see that everyone's using ROS and standardizing on that in talking to the robots. I'm wondering if there's any progress on a standard, just environmental representation that can support XR. I mean, we're going well beyond the usual just PGM 2D flat file for SLAM that everyone kind of just stacks stuff on top of. Is there any standards being developed on this?
I guess I can start. I'm not really aware of any standardization on that. I think it's still like doing this really properly or the right way is still kind of an open research question. So, I mean, I have my own personal opinions about what's best, obviously everything I've done. It's not, but I think it's still kind of a open field where there's no clear solution. So I would think we're quite far from standardizing. I think we're getting closer to, getting stuff that actually works off the shelf, so you can try it out and see if it's right for your application or not. But I think having one solution that fits all, I'm not sure that'll ever be the case, to be honest.
And I also don't have, this is sort of a non-answer because I also don't have any updates to share on any kind of standardization in terms of environmental representation, but I can to sort of follow on with some, maybe higher level thoughts on the results that I showed in my talk. I think, or at least the perspective from the team that I work on is the robot doesn't necessarily need to have its own full environment representation in order to utilize cloud services that can provide specific functionality that the robot will need in order to perform tasks. So the examples that I showed in the talk, localization, navigation type services, global navigation, particularly when you move to maps of really large spaces, it's not necessarily feasible for each embedded platform to have a full dense representation of the map and do all the computation around using that for example, path planning or collision checking. But if that's something that can be done with more powerful computers in a cloud service, and the robot still maintains its own possibly proprietary local representation of the world, and only gets the pieces of information that from the cloud service that are really relevant for it to then perform its task. In the example that I gave with navigation, we don't touch the onboard obstacle avoidance with on spot. It's not available to the user. We just give it a sequence of waypoints that are 1 meter apart on the way to its goal, and it does everything else in kind of black box in there, which is a reasonable expectation to put on a lot of robot platforms, that they can drive a short distance and not hit anything. based on whatever algorithms they're using for local path planning and local obstacle avoidance. And so I think that's a good question, and one that I don't think the research or industry community has really settled on as far as how best to represent environments, especially with all of the different types of spatial information we could want, semantics and geometry and all of that is, you know, I think we're probably moving farther away from having any kind of standard than the 2D PGMs you mentioned. But I think we might be moving in a direction that it's not really necessary for each robot to have all that information, and instead to just get the pieces it needs from some central server.
All right, thank you.
Okay, we probably have time for one more question. Yes, please go ahead.
Hi, this is also more of a question for Dr. Oleynikova. So how would on the latest application that you showed, you were doing live streaming of a reconstructed mesh. How is that being handled? Are you sending the mesh at all times, the whole mesh at all times, but that's like, you know, bandwidth intensive, or are you just sending mesh updates? If so, how are you handling the incongruences between, you know, the reconstruction at different time steps if you have uncertainty in your tracking? Thank you.
I'll just, before you answer, I will just add this question also to Dr. Liu with his volumetric telepresence streaming. Go ahead.
I'll go first, since again I'm holding the microphone. Yeah, so that's a really great question. So I will say I can't 100% answer for what they were doing in that demo, but what NVBlocks does and what I've standardly done is, yes, so streaming only mesh updates. So in these systems, we use a concept called block hashing or voxel hashing, where the world is kind of split up into 3D blocks. You keep track of which ones have changed, and then in the renderer, you basically get just a list of updated blocks, and then you delete whatever was there and replace it with a new mesh reconstruction. This is not like so this is good because you basically only update stuff in the field of view. It's not perfect because you still do a lot of redundant data. If you're sitting there staring at the same thing, you constantly update the mesh blocks that you're looking at, even though, you know, really the structure doesn't change that much frame to frame. So there's a lot of compression to be done there as well, but this already cuts it down a lot from streaming the full mesh. So yeah, you just break up the world into blocks, have an index for each block, and only update the blocks that actually had the structure change.
Yeah. From what we are doing in terms of streaming the volumetrics, I guess for us is that the goal for us is to stream the live 3D representation, slightly different from streaming a map. So the goal is really just to make it as fast as possible and retain as much as the original sensor data as much as possible. So what we have developed is what we call statistically lossless compression for depth map. That's so that's basically streaming the depth image and compress it, stream it, and decompress it in a low latency, low bandwidth fashion. So what we do is the quantize data in a more efficient way and stream that. And what the user gets on the VR side is the slightly distorted the depth image, but majority, I think it's like 99% of the original data is maintained. And we reconstruct that with mesh renderers, and we have the UV mapping of the RGB image as well. So that RGB image add on top of the mesh in a separate pipeline. That's quite different from the point cloud, because the point cloud you can only have one pixel per point. But in our case, we can have a low resolution depth as a depth image, and then we're UV mapping it to the mesh, you can have high resolution color information on top of that. And so that's one direct streaming, but also with multiple camera fusion, that's a bit similar to mapping pipeline, I guess, where you want to fuse multiple cameras, RGB information. Well, we do utilize the TSVF, and I think a lot of what Helen mentioned could be applicable to that pipeline. Yeah, well, we're interested, actually quite interested in the UV and the blocks. Yeah, we were good followers for the Vox blocks pipeline, but yeah, there's a good information for us that
NVBlocks is faster.
Yeah, that's definitely helped a lot on that, and yeah, we'll explore that definitely. Thanks.
Okay, thank you. I think that was yeah.
I mean,
So
if I could follow up without
if you have follow up,
yeah.
So go ahead.
If you use the voxel block rating strategy, right? When you update just parts of the mesh, won't you have like some incongruences around the edges?
Yeah, so we kind of, well, so it's not super likely to happen because we update the whole block if anything in the block changed. So unless your field of view really lines up with the edge of the block, which can happen, yeah, then your mesh is only as good as your map. So if you have discontinuities in your map, you just kind of have to live with that. So, and I mean, this is kind of a detail, but we don't mesh from both sides. We only mesh kind of from one side of the block. So you only mesh up and to the right and whatever. So you don't get the same triangle from both directions. You only get it from one direction, which then also helps a little bit around block boundaries. But yeah, if there's a big discontinuity at the edge of your field of view, you'll get a discontinuity in your map. I think no way to avoid that, or we don't do anything to avoid that.
Thank you very much.
All right, thank you. So that was time enough for the panel discussion today. Let's thank all our panelists, Dr. Nakakura, Dr. Oleynikova, Dr. Delmerico, and Dr. Liu.